Okay, so we are now doing Curiosity 3, question 4. Question 4, find the domain and the range of the following functions. Now we did the domains and the range of functions. We're able to obtain, we categorize them as two types, where the first type had a function of this nature, h over g. The second type had a function of this nature. We also had a combined one where you could get, suppose the h is the one in the root and the g is standing alone. We also had a function where the h up is not in the root, but the g is in the root. And we're able to get the domains of these functions. So let's see if we can apply our knowledge on question 4. Question 4, part 1. We are being asked to find the domain of the function of this nature, 1 over x squared plus 1. Remember, we said this is supposed to be under this, where we said g should not be equal to 0. So x squared plus 1 should not be equal to 0 to form our domain. Now, is there any value of x that is real that can make x squared plus 1 to be 0? We don't have such a value. So because we have no x that can make the denominator 0, our domain is just the whole U line. That's how we check. So x is squared, whatever value of x that you take there, you will square it first before you add 1. So if it was negative, when you square it, the negative will vanish, and then you're going to add the 1, which is positive. So you avoid 0 at all costs. The second piece is f of x is equal to 1 over x minus 1. Now, are we able to get the domain of this? Of course, yes. X minus 1 should just not be equal to 0. So we don't need to allow x to be 1. So the domain can be any value of x for as long as it's not 1. But it must be a real number. That's how you read the domain. So you say the domain is any value of x that is not 1, but a real number. Or you can write this as x, a real number, such that it's not equal to 1. It's the same. So for such types, there's nothing hard yet. Let's see. F of x is equal to the root of 1 minus x squared. How is this? We are saying it falls under here, where we say g of x must be greater or equal to 0. So we have 1 minus x squared to be greater or equal to 0. Now, this is the difference of two squares. So you say 1 minus x or 1 plus x should be greater or equal to 0. So this falls under inequalities that we have not yet done. So I'm going to introduce the inequalities here on this question so that we would not leave it until we do inequalities. So what happens is that whenever you have a product on the left under inequalities, if there's a product or a fraction, then you will solve what you call the critical values. So where you say 1 minus x is equal to 0, implying that x is equal to 1. 1 plus x is equal to 0, implying that x is equal to negative 1. Now, these two values of x are what you call the critical values. You can separate them in that way get a number in between them. 0 is in between -1 and 1. A number bigger than 1, say 2, less than -1, say -2. Then what next? Get 1 minus x, get 1 plus x, get the product also. Separate like that. So I've used the table. So this is the table. What next? Get -2 and take where there is x. So you have 1 minus -2 for the piece 1 minus x. This will give us 1 plus 2, which is equal to 3. Our interest is in the sign. We've gotten a positive there. In the same function, let's take 0. It will be 1 minus 0, which is 1. We have gotten positive again. In the same, 1 minus 2, we'll get -1. We've gotten negative. Then come to 1 plus x. Get 1 plus -2, which is -1. So I've got a negative here. We go to 0. 1 plus 0, which is 1, which is positive. 1 plus 2, positive. So we have positive there. Now the critical line is the third one. You multiply plus, this plus times this negative here, we'll get a negative. Multiply plus times plus for the middle part, we get plus. Negative times plus, we get negative. So the solution set, which in our case is the domain, is going to be where it is greater or equal to 0, meaning where it is positive. Anything bigger than 0 is positive. So you start from -1 all the way up to +1. So you do not so what you do is you never get to use these numbers in the solution set. You never get to use these numbers. You use the number that you have found as the values of x. The ones we have called the critical values. These are the ones that we use when forming the solution set. Now, in our case, it's not just a solution set, it is the domain because we are looking for the domain. So we have found the domain of this function. So this issue of the table comes so we use the table whenever, 1, we have a product. 2, we have a fraction. So these are the only times when you think of a table. When you have a fraction or when you have a product. Always, if you see this, use the table. When I say the table, I also mean the number line. So when we do the inequalities, I'm going to demonstrate how the table is the same as the number line. So we needed this just for us to obtain the domain. So we have another one. The fourth one, f of x is equal to the root of x squared minus 1. Again, x squared minus 1 should be greater or equal to 0. So x minus 1, x plus 1 is greater or equal to 0. Because we have a product, we'll use the table. Okay, so because of the product, we will use the table or number line. So now we use the number line. So we obtain the critical values. So x minus 1 is equal to 0, or x plus 1 is equal to 0. So x is 1, or x is equal to -1. Then we use a number line. So you put -1 here, you put +1 there. Pick a number bigger than 1, say 2. A number in between, say 0. A number less than -1, say -2. And then get the whole thing, x squared minus 1. When x is -2, we are going to have -2 squared minus 1, which is 4 minus 1, which is 3. It is positive. So meaning it's positive from here going this side. So I'm including the boundary numbers because I have greater or equal to. Okay, so we get 0. We have 0 squared minus 1, which is -1, and negative. Okay, negative from there all the way up to that number. That is negative. You use 2, so 2 squared minus 1, that is 4 minus 1, which is equal to 3. Positive. So from here, positive all the way up to this far. So what is happening? We have the domain, which is a solution set. We want where it is greater or equal to 0. So from -infinity all the way up to -1, included union, start from 1 all the way up to +infinity. We have left the part where it is negative because we want where it is greater or equal to. So the equal to part has made us include 1, also include -1. Is it okay? So now we can see how, okay, good. We can see how the number line is giving us the exact solution as the table. We have the required thing. All we need are the signs. If you use the table, you want these in ready. If you use the number line, it's the same story. You just want the signs, plus, minus, plus, and then pick the plus if it is greater or equal to 0. Pick the minus if it's less than 0. Okay, so we go to the fifth. F of x is equal to the root of x squared plus 1. Remember, we want x squared plus 1 to be greater or equal to 0. The good news is that this x squared plus 1 will always be greater or equal to 0. Why? Because every value of x when squared will be positive. Will be positive. So when you add the 1, automatically it is positive. So what will our domain? Our domain will be all real. It's defined for every real number. So here, if you want, you can say every real value of x when it's squared will be positive, because we always deal with real numbers in such functions. The sixth one is a bonus, where f of x is 1 over x. What's the domain? It can be any x, which is a real number, provided that x itself is not 0. It can't be 0 because it's in the denominator. Okay. So if I add something on the same question, I'll call it the seventh part. F of x is equal to root x plus 1 minus x. Find the domain. So how do you get the domain of this function? We know that the first thing is that x should be greater or equal to 0 for this piece. 1 minus x also should be greater or equal to 0. Now for this one, it implies that negative x should be greater or equal to negative 1. Divide by negative, it will mean that x should be less or equal to positive 1. So now, this one is telling us that x must be greater or equal to 0. This one is telling us that x must be less or equal to 1. So our domain will be the intersection. So you start from 0, it must be less or equal to x, but this very x must be less or equal to 1. Okay? Provided they are real numbers. I can write this also as 0 to 1. So take note, we get the intersection of the two domains of each function. So you've seen that the first function has had its own domain, second function has its own domain, but they are all for the same function. So we combine the two domains, we get the intersection, we get where they are both defined. So if you drew a number line, you'd have seen that the other one is saying x is bigger than 0, so it's starting from there, going this side. The other one is saying x is less than 1, starting from there, going this side. So ours is to get the intersection where you have two lines. Okay. So before you forget about this part, you have to do, you find the domain of f of x is equal to the root of x plus 1 over the root of x plus 1 over the root of x minus 7. The second one of f of x is equal to the root of x squared plus root of x squared plus 3x plus 2 plus the root of x minus 4. Very friendly. Hint, factorize x squared plus 3x plus 2, 1, 2, get the critical values, use the table or number line. Okay, then get the domain. Get the domains and get intersection of the two domains. Hint here, get the domain of the numerator and of the denominator, then get the intersection of the two domains. So it must be a simple task. We also are giving you the guidance. So once you factorize, you have a product. So you have a product of this nature. Then you have the critical points. So use them in this manner. Remember, it will always be greater or equal to 0. So you get a positive because what you have is in the root. From there, get the domain of x minus 4. Then intersect the two domains. For the first one, they're direct, domain of numerator, denominator, then get the intersection. Okay, so we go to question 5. If f of x is given as 2x squared plus 2, g of x is given as x minus 1, h of x is given as 3x. What do we find? Find f of g of x. The first step here is to take g in f, meaning you go to f, where there's x, you take g. Because we know what g is, we can substitute, which is 2x squared minus 2x plus 1 plus 2, which becomes 2x squared minus 4x plus 2 plus 2, which is 2x squared minus 4x plus 4. That is the composite. Also get g of h, 2 g of h. So g of h, the first thing we do is we go to g and take h inside, meaning to g where there's x, you take h. But you know what h is? it's 3x. We are done. So let's see. Okay, we still have nice examples down here. So the ones that are here, they are all easy. On B, so this was A. On B, so no matter how easy these questions are, we must do them. Because sometimes we take advantage that they are too easy, and then in the exam they come. Then we mix up concepts. So we need to be doing, even what looks to be simple, you try. It's part of your exercise. So it's part of the practice. So I'll give you to do this one. So do the whole B. It's not complicated. So that we go to question 6 and spend some time here. Find the inverse of each of the following functions defined by the following equations if the inverse exists. If the inverse does not exist, for the largest possible domain, limit the domain so that the inverse will exist. In each case, give the domain and range of both the function and its inverse. 1. F of x is equal to 2x plus 3. Find the inverse of this function if it exists. So to find the inverse, we let this be y, and so for x. So we have y minus 3 is equal to 2x, divide by 2, divide by 2. So x is y minus 3 over 2. That is f inverse of x is x minus 3 over 2. Then, in each case, give the domain and range of both the function and its inverse. So let's give the domain of f. The domain of f, this one is just all real. How do we know? Any value of x that we take there, the function will be defined. So it is all real. Let's see the domain of the inverse. The domain of the inverse, again, its denominator is constant, 2. So any value of x we take there, the function will be defined. So again, we have all real. Let's go to the range of f. The range of f is the domain of the inverse. So it's all real. Let's go to the range of the inverse. The range of the inverse is the domain of the original function. So it's all real. So what have I said? I'll repeat. The domain of f is the range of f inverse. 1. 2, the domain of f inverse is the range of f. Okay. So this question is, so we have nice questions here. We have about 1, 2, 3, 4, 5, 6 remaining. In 6 minutes, we won't finish them. So what we'll do is we need to log out before we continue. But we're supposed to come back immediately after log out, but we have an exercise to do. We have 2 questions here, 1 and 2. So this is here it's 14:47. 13 minutes from now, it will be 15 hours. So 13 minutes plus 2, that is 15. So at 15:03, the class will be starting, meaning we'll start logging in at 15:02. So you have 15 minutes to do the task. You can start. So just screenshot because I will be cutting this. Okay, so I hope everyone has done the screenshot. You can start.